Okay, so this is 2019 number 5 from the BC test. So we have the function f of x equals 1 over x squared minus 2x plus k. And part A says, find the value of k such that k is greater than 0. Set the slope of the line tangent to the graph, so the slope of the tangent line is 6 when x equals 0. All right, so I'm going to take f prime at x, the slope of the tangent line. Now, before I do that, I think it would be easier to take the function f of x and rewrite it as x squared minus 2x plus k to the negative first. So now when I take f prime at x, I get negative 1 times x squared minus 2x plus k to the negative second. That's using the power rule. And then the chain rule, the derivative of the inner function, which is 2x minus 2. So I have f prime at x equals negative 2x minus 2 over x squared minus 2x plus k quantity squared. So I'm going to take my f of x and replace it with the 6. And I'm going to replace x with 0. So I have negative 2 times 0 minus 2 over 0 squared minus 2 times 0 plus k squared. So I have 6 equals 2 over k squared. So k squared equals 1/3. So k equals plus or minus the square root of 1/3. And because we were told k had greater than 0, we are going to say that k equals 1 over the square root of 3. 5, part B, it says that k equals negative 8. And we want to find the value of the integral from 0 to 1 of f of x dx. And we know that the integral of f of x is equal to 1 over x squared minus 2x, and then putting in the negative 8 for k dx. So if I want to integrate this, I don't have the derivative of the inner function, the 2x minus 2. So the straight up u substitution isn't going to work. So I am going to use partial fractions. So if I go with partial fractions, I'm going to factor this. So I have 0 to 1 of 1 over x minus 4 times x plus 2 dx, and break that up into my partial fraction. So I have a over x minus 4 plus b, and I probably put that equal sign there, b over x plus 2. So I have a times x plus 2 plus b times x minus 4 has to equal the numerator of my fraction, which is 1. So I'm going to choose x equals negative 2. And when I choose x equals negative 2, I get b to be negative 1/6. And I'm going to choose x to be 4. And when I do that, I get a to be 1/6. So I can now go back to my integral and replace it with an equivalent form. So I have the integral from 0 to 1. I'm going to take a 1/6 multiplier out front. And I have 1/6 I took front, so now I'm just going to have 1 over x minus 4 plus, and again, I have a negative b, so I'm going to write that as 1 over x minus 4 minus, because I took the 1/6 out, 1 over x plus 2 dx. Again, the 1/6 from the a and the b I put out front as a constant multiplier. So now I have 1/6. When I integrate, I have the natural log of x minus 4 minus the natural log of x plus 2. and that's going to be from 0 to 1. So I have 1/6. Putting in 1, I have the natural log of -3 minus the natural log of 3 minus, putting in the 0, the natural log of -4 minus the natural log of 2. Again, these are all in absolute values. So simplifying, I get 1/6 the natural log of 0 here. So continuing now to number 5, question number 5C. It says for k equal 1, find the value of the integral from 0 to 2 of f of x dx. So that's going to be the integral from 0 to 2 of 1 over x squared minus 2x plus 1 dx. Now, the key to this is to recognize that if k equals 1, we put that in, and if we factor a denominator, we have 1 over x minus 1 times x minus 1. And so that tells me that I have, and so I can rewrite that as minus 1 squared. And that tells me that I have a vertical asymptote at 1. So my graph 1. Now, what is happening to this graph? 0. Well, as x approaches 1 from the left, this is going to go to positive infinity. And as x approaches 1 from the right, this is going to go to positive infinity. So I have to write this as 2 separate integrals. I can't just integrate as one integral because I have a break in the continuity. This is not a continuous function. So I'm going to take a limit as t goes to 1 from the right of the integral from 0 to t of x minus 1 to the negative second dt. And I'm going to add to that the limit as t approaches 1 from the left of the integral from t to 2 of x minus 1 to the negative second dt. Breaking it up into 2 integrals because the lack of continuity in the functions. Okay, so now I'm ready to integrate. So I have the limit as t goes to 1 from the right, and I'm going to have x minus 1 to the negative first over negative 1 from 0 to t, plus the limit as t approaches 1 from the left of x minus 1 to the negative first over negative 1 from t to 2. So I have the limit as t goes to 1 from the right of negative 1 over x minus 1 from 0 to t, plus the limit as t goes to 1 from the left of negative 1 over x minus 1 from t to 2. All right, so I have the limit as t goes to 1 from the right of negative 1 over t minus 1 minus a negative, so t plus, putting in 0, I would have plus a negative 1. Plus the limit as t goes to 1 from the left, putting in the 2, so I have negative 1 over 1 minus a negative 1 over t minus 1. So as t goes to 1, let's just evaluate our limits. As t goes to 1, as this to 1, this is going to 0. As that goes to 0, this will go to negative infinity. Because as a denominator goes to 0, the fraction goes to infinity. And once we get a negative infinity, all of the rest are out. We need to worry about them. this is going to diverge. And since it diverges, we are going to say the integral from 0 to 2 of f of x dx diverges.